Well, hello, this is Mike Barsick and
Ali
from Southface, and we are here to talk about a quick overview of the new resource that we have available, the Georgia 2020 Residential Field Guide. This is a great tool, and it's gone through one slight revision, so it's at the moment it's version 1B. Who's to say there might be other revisions? Those tend to happen down the road. But yeah, absolutely. But I also want to mention that there are a couple of other resources that you can get in the same place that you get this from, and make sure people are aware of some of these because I think they're useful. And I'm going to show you those. But we'll kind of walk through the field guide and make you aware of a couple other resources. And some of them are more for existing homes, and some are more for new construction. So hopefully you might find folks might find some of this useful. Okay, so Ali, probably the most important thing here is this website right here.
Yep.
That's where you want to go. And once you go there, then you go, where is this stuff? So I have pretty much written, to me, the shortcut way. I wouldn't exactly call it a shortcut. The best cut way to get there, which is southface.org, and then education, our courses, energy code, and then under energy code there's a Georgia Energy Code resources and support documents, and so that's where we're going to go. And I'm going to pop out of here, and I guess while everyone is aware of it, is that just a quick reminder that we're talking about the 2020 Georgia Energy Code, which is based on the newer 2015 IECC with Georgia supplements and amendments. So we'll talk about that in a second. The Georgia supplements and amendments come from the Department of Community Affairs website, but I believe we also have them posted on our website. So with that, I'm going to jump over here to some web browsers that I have open, and I thought it might be good just to start from the very beginning and try to show where some of these are. Yeah, it's a little amusing. But anyway, so if you go to southface.org, maybe we should go all the way up to our homepage. Yeah. Where's the homepage? I don't know. There you go. That'll work. And so when you first pull up southface.org, you get a picture, a lovely fall autumn picture of our building, and a little bit of our organization. But if you come under here, across the top, you click on education, our courses, and then you don't have to click education, just hover over it and drag it down. And then you come down here, you see a bunch of them, and you're going to look under energy code. And then you come down, you'll see a few different things. But at the bottom is Georgia Energy Code support documents, and that's what we want to go to. And that screen has a lot of good information on it. So this is kind of a quick, overview of this, the GFA grant that Southface and the DCA received, and able to really do a lot of education and outreach, lots of live trainings, as well as create some great tools. First thing that shows up, Ali, is two really handsome men right there in a video that says duct and envelope tightness verifier training. This is a video we made. What was who was the audience of this, if I remember right? Pre-existing DET verifiers, just kind of
giving them an update on the content and what's changed.
Yeah, it's not teaching you; it's more like here's what changed. Yeah. So that was we did that one, and then more recently we have this one too, which is a walkthrough inspection and visual walkthrough inspection just at pre-drywall. So that one has a lot of good information on it. And you can watch this one. This is really targeted for that kind of brief window of opportunity before drywall goes up, when we want to make sure that all the air sealing and insulation at that point has been done correctly, because it's going to get covered up. So I think that's a really important one. So those are two good tools. Just while we're on it, a couple other things over here. So I'm going to just scroll up a little bit. Is over here on the right side is where a lot of downloadable stuff is. There's a example of a one-page summary of the changes to the residential code. There's the other side of that has an example of the DCA's energy code certificate that might be getting slightly tweaked in the future, but that's coming up. All the slides for the residential code are right here, and all the slides for the commercial code are right here. And a couple pages out of the IECC, the residential chapter, are here. And the DCA supplements and amendments, I think went ahead and put them here as well. And there's a couple little graphic glitches in Appendix RA of that we'll get those cleaned up eventually with DCA. But there's a clean version of the graphics that you can download right here. And that's a lot of air sealing and insulation details. So some of that makes its way into the field guide, which we'll be talking about. Scrolling down, there's a couple other things that you might find useful. There's one about appropriate ways to do fresh air in houses. And the one we really want to focus on is the 2020 residential field guide. Please note there's also a commercial one. And I believe this is a translated version in what language? That looks like Spanish to me. So I'm not going to click on that one right now, but hopefully that will help you out and be useful to you. I did want to also point out, because we get a lot of questions in our trainings about combustion safety. And even though it says light commercial or it says commercial combustion safety, it's identical for houses. So if this comes from another section of our website that I do want to show you where that is, some research we had funded about light commercial. We wrote a little workbook for Excel that if you know what you're doing, it'll crunch all the math for you. It'll help you figure out, is it a confined space or an unconfined space? Do you have adequate net free area for your high-low vents and things like that? But the one I think it might be valuable is, if you're interested in this topic about combustion safety, is to read this right here. It says small commercial, but it, again, could apply to houses just as easily. This is I think it's about 50 pages, so I don't want to scare people away. It's almost all pictures, because that's me. Ali, have you figured out I have a short attention span? So there's a lot of good pictures in there, and it also kind of promotes that this is about context. So it's about the context. It's not necessarily, is the water heater safe or not? Is the water heater safely installed in the context of this building? So that's a really good resource I want to make sure people are aware of. If you're interested in knowing more about the residential field study that Georgia participated in, and actually their data was from 2015, you can see that, and a lot of good results out of that. There's some other good stuff on here that I just want to reference and make sure people are aware of as well. So lots of good information. And while we're at it, I'm going to leave here. This is where we're going to get lost. But if you go under, if you do a lot of work with existing homes, or I've had a lot of people in our trainings that are, you know, they get excited and they want to make an improvement on their existing home. So I want to show people in a very different location under resources. This is technical resources. If we scroll down a little bit, we had some heavy funding called Advanced Commercial Building Initiative. I call it ACBI. And there is a ton of good information in here. And this is mostly light commercial stuff. But there's also something that has arguably the worst title of anything that we've ever come up with. Ali, can you read this for me?
Yeah, it's Energy and Water Efficiency Project Implementation Verification Checklist, or as we call it, EWIP.
EWIP or something, yeah. So we could probably come up with a better name for that. Someone suggested Retrofit Guidelines, which I think is probably a better name.
Yeah, I think
anything is better than that. But when you click on this, it's a Word file, and it actually is, I think, something that people might find useful. And in the very beginning, it's just some really good sort of I want to get this improvement done on my house or my commercial building. What are some questions I should be asking? Or, you know, I'm probably not going to do it myself. I'm going to sub it out. But what are some questions I should be asking? And so here's some examples of the different improvements that we're talking about. I can never make that go away. There we go. And each one is usually about 1 or 2 pages long. And so you know, everything from, I want to retrofit spray foam on my roof line. I used to have a vented attic. What do I need to pay attention? What questions should I ask? What are details I should look for? How do I make sure that they've done the job correctly? And so on. Here's another one. I've got a flat attic and I want to install insulation, but before that, I want to make sure I do air sealing and what we call insulation prep. So I think these will be really useful. These are, in essence, projects that you could do on your house or your commercial building. And let me just scroll down to one and just see what it looks like. That was, and you can see it's pretty much just a checklist in most cases. Here's one: flat attic air seal and insulation prep. So we want to do this before we install any insulation. We make sure we do air sealing. We want to block attic knee walls. We want to make sure can lights are correct. Dams so blown insulation doesn't clog up the eaves. E-vents. So it's nice to sometimes, it's a nice detail to put a flag or some sort of indicator everywhere there's an electrical sealing box. It's just nice to know with a little flag that right down here is where a box is. Talking about attic access, and then some best practice things about elevating any storage up there so you can get the full R value underneath it. Details like that. And then you come down to the actual details of installing insulation. What are the things you want to pay attention to, and so on. So that, I think, is a useful tool. And what's that called again? I can't remember. I'm going to go back here and go, it was, wait, it's right there. There it is. Energy and water. Read it again, because I think that's exciting.
Yeah, the Energy and Water Efficiency Project Implementation Verification Checklist.
Wow, that's a great name. So anyway, we have, I just want to make sure everybody was aware of that, but the main thing I want to walk through today is a overview of the newest sort of user's guide to the Georgia Energy Code is called the Residential Field Guide. So I'm going to, again, show you how to find that. Go to Education, Courses, and then you scroll down and you got Energy Code, and again, Georgia Energy Code and Support Documents. And then over here on this right side is a list of all kinds of goodies, and the main one is that one right there. So you click on that, and it'll take you to it. I would recommend you download it. So I've got a version that's already pulled up right here. And this is what the cover looks like. So it's about 75 pages. We're on somewhere I can zoom in. I think we're on version 1B. And
just make sure you guys, that's the one that you're looking at.
Yeah, yeah. And chances, or later, maybe there's a later version, because, you know. So anyway, then we come into the field guide. And the way this thing works is, I think I'll zoom in on this and talk about it. So what we tried to do is kind of take a different direction with, you know, reading the energy code and trying to, you know, use code speak and things like that. So what we're trying to do is help explain the code. And yes, it's not necessarily every aspect of the 2015 IACC for residential housing. For example, I don't think there's anything here about snow melt systems, Ali. Do we have a lot of need for that in Georgia?
Absolutely.
How about in Florida, where you're from?
Except when we get like maybe that like snowflake that shuts down.
The one snowflake that shuts the 2 inches, right? So it's a snowpocalypse. So anyway, so this is a tool, again, for the major parts of the code. And again, it's I would say the biggest thing here is the way it's laid out. So it's laid out not in the flow or of information via the code. It's laid out by component. So you think about it, you're building a house, you've got exterior walls. Okay, we'll go to the exterior wall, and everything you need to know about exterior walls from all the different sections of the code is in one place. And it kind of, with bullets, tries to describe what we're going to do, and then after we've described it, I want to see pictures. So lots of pictures and diagrams. So I think that's the big thing that makes it hopefully more user-friendly. And again, it's based on the 2015 IACC with the Georgia 2020 amendments. And occasionally there's some content that references the latest version of the IRC, which is the 2018 version in Georgia. So again, this is where you can find that information we saw earlier. But again, thanks to the great folks that worked on this. Content-wise, There's an introduction, which is very useful because it gives you this overview of kind of where we are in the code and how we got to where we are. But then really it dives into components. So a little bit of generic information about all insulation and what we're looking for, but then it gets into components: slabs, basements, crawl spaces, walls, floor, walls, ceilings, details with baffles, attic access, attic knee walls. And I am reading these, but it's kind of on purpose. Windows and then glazing, view factor and solar heat gain, air leakage, and then a lot of stuff, can lights, a lot of stuff about air sealing, a lot of details about air sealing and insulating. Again, with pictures. Do you like pictures, Ali?
Yes.
I like pictures.
No one likes looking at a whole lot of words.
Especially code. So, so that's kind of, I'm scrolling down so people can get a sense of it. You know, lots of air sealing details, and we'll look at it in a second. But the idea is that, you know, we can go to this section. There's also stuff about mechanical systems in here, and blower door and duct testing, and the certificate. And at the very end, the newest requirement of Georgia Energy Code is that all houses have to have a heated swimming pool. Is that really a requirement? I guess if you have that, you have to go here. So if you don't have one of these in your house, you can skip it. Lighting is something most houses have. So we'll see that. So it's a good way as we go through. I'm not going to read this whole thing, but as we go through, I'm going to try to highlight and recap a lot of the stuff that's actually in the code. So if you watch this and look at the pictures. Oh, and I think, Ali, isn't this supposed to be phone friendly?
It is. The whole PDF can be pulled up on your phone.
And zoomed?
Take it to wherever you are. Yep. Zoomed in and everything.
Wow, that's pretty slick. So the idea is that you can have this with you. You can check on a topic or something, and that will help you out. So I think that's pretty slick. So here's a little bit of why this is important and the basic impacts. How we got to here. We were involved in a field compliance study that showed that we actually were doing pretty good on our 2011 based energy code, but they showed room for improvement on 4 main areas: the way we install insulation, the tightness of houses, the tightness of ducts, and then more efficient lighting. The new code goes from 50% efficient light bulbs to 75%. And Ali, when I say efficient lighting, what technology do we want people to go to?
LED.
LED all the way. So it's really one of those economic no-brainers. Okay, and it talks a little bit more. So the big changes and highlights, honestly, in terms of R value, not a lot of changes. Ceilings for climate zones 2 and 3 go to 38, but they're already 38 and they stay there for zone 4. Windows kind of get better on paper, but they're the same windows everybody's using. Houses get tighter. They go to less than, we're supposed to go to less than 3, but we're going to less than 5. And ducts get tighter. It's supposed to go to less than 4% leakage rather, and instead we're going to 6%. But that's still significantly tighter. And a couple other little clarification things about lockout thermostat for electric heat pumps in the wintertime. And a little bit of oversizing of mechanical equipment is allowed because of a Georgia amendment. It's really to encourage variable speed equipment. Ventilation is a very good idea. Fresh air for homes, it would have been required, but Georgia amended that to not require it unless the home was less than 3 ACH 50. Homes has to be less than 5, but if they're less than 3, they must have fresh air. We would certainly recommend that for all houses. And this is kind of new, hot water pipe insulation for certain spaces and areas, and that's also covered in the code. The way you can show compliance with the code is most people would just simply meet the prescriptive code. You can do a simple trade-off using res check or a hand UA trade-off. I think we have a webinar about how to do a hand version of that. Res check is a great tool, but it's going to assume your walls are R20, which is meaning most of the states or climate zones 3 and 4 are going to kind of have to work uphill. So I don't think res check is going to be such a useful tool. You can still do this annual simulation. Not a lot of builders do that, but they also have this new HERS or ERI compliance option. So that's a new option in the code. Here, basically, if you get a 57 on your HERS index or 62 in climate zone 4, 57 in zones 2 and 3, you automatically pass code. And then you always have mandatory requirements. So Ali, here's a really hard question for you. Can mandatory requirements be traded off?
No, absolutely not.
Oh, that's why they're called mandatory. Okay, so that would be an example of something like, air sealing is mandatory, or sealing ducts with mastic. That's a mandatory requirement. And again, without going too deep in the weeds on this, this is kind of showing if we adopted the 15 code as written, everything with a red box represents what would have changed. What we did is actually what's the blue box down here. And that's actually summarized in the appendix, in the Georgia amendment. So I was going to pull that up and just show that document. That is not it. That is it right there. So that's the prescriptive energy code in Georgia's supplements and amendments, which you can download off of our website or off of TCA. But it's more or less reprinted here in the field guide. So find your climate zone. And there's also an important table. I always call it, and there's those two tables. There's also I call it the can't trade it to zero table, which is down here. So no matter what trade-off you do, your building cannot be worse than this, and your windows cannot be worse than 0.5 U factor or 0.30 solar heat gain, and those are weighted average. That should be on that table, but I don't know if I don't see it. But moving forward, and here's a little more detail about the different trade-off approaches that we just discussed. So I'm going to kind of skip out of that and say, okay, there's a very important Appendix RA that talks about air sealing and insulation key areas. And a lot of this, particularly the stuff that gets inspected at pre-drywall, you should watch that little video we pointed out earlier. That's a good thing. This is basically the same code as same table in the code, but Georgia amended it or modified it just slightly, but mainly just put numbers by it. And so these numbers apply to graphics in the Appendix RA to help illustrate it. And again, it's not trying to show every way or every technique, but it's trying to show examples. So we'll see that in this guide. And finally, if you haven't figured out what climate zone you're in, that it's all based on counties. So figure out what county you're in and go there. All right, at this point, Ali, we're actually into the document itself. So I'm going to just sort of say, this section is about insulation R values. It really kind of gives you the basics. And you'll notice that it references different sections of the code. Like some of this comes from Chapter 3. That's kind of manufacturer's directions about labeling R values and things like that. And some of it comes from Section 402.1 or 402.2. So we'll see that. And again, I'm not going to read it. And also, Georgia wrote a spec of go or no-go for installing insulation. So for wall and ceiling insulation, your voids and gaps have to be less than 1%. And those are places you could see right through or literally stick your hand through. There's no insulation at all. And that has to be less than 1%. It's subjective, but it's a way to sort of say good enough or not good enough. And then as for compression or incomplete fill, it has to be less than 2% of the insulated area, but the amount of compression has to be less than 1 inch. So if it's supposed to be 3.5 inch thick cavity and you've compressed it because of a wire to 2 inches, that's a fail right there. And there's a lot of graphics and stuff that'll go with that as well in the appendix. So details with underfloor as well. So slab edge insulation, there's not much to say here. You don't have to insulate the edge of a slab. There are ways of doing it, but most builders choose not to do that. Basement wall insulation, this is one that we really do encourage. You can see all the different sections of the code that might be referenced, the different R values based on the climate zones. And here's a definition and kind of the basic information. So, you know, in a daylight basement, which is pretty common, this is a stud frame wall that gets insulated usually with an unfaced insulation. The concrete, by definition, is more than half below grade, so that's the basement wall part. And it's R5 in climate zone 3, and it's R10 in climate zone 4, and it's R0 in zone 2. Probably don't see a lot of basements in Savannah. So here's some examples of ways to do basement insulation. And again, if this is climate zone 3, that concrete has to be insulated. It can either be studded up against it or R5 continuous. Here's some more basements. Here's more basements. I'd have to turn this. Can I do that? Do you think I can pull this off? Rotate view.
Yeah.
You really? Wow. What do you think? Here's a whole bunch of basement wall details. And actually, I think this 3-inch inspection strip is really just for crawl spaces. So it's not a bad idea necessarily for basements, but basements usually, they're looking in the band area. But anyway, you can do different types of insulated board. There's a rock wool based one. There's fiberglass like duct board. There's certain types of foam board that you have to cover with drywall. There's other types of foam board that you can leave exposed. Blanket insulation, sprayed on, and a studded wall. If you're going to do a studded wall, which is not my preferred approach, it's very important to be up against the concrete since that's the air barrier. And then of course the drywall is, if you're going to finish it, that's great, but usually in this stage of construction, the drywall is not, it's an unfinished basement. But we really believe strongly in trying to encourage people to insulate walls of basements, because that is going to get all the ductwork and air handler inside the envelope. You don't have to mess with all the bad underfloor insulation details and holes in the floor. It works better, I think, is the key thing. And of course, your ductwork is inside, so that's a big one. All right, I'm going to scroll down, and now I have to rotate this back. I hope you're impressed with this, Ollie, because I've successfully rotated. So crawl space wall insulation, similar to basements, they do have that view strip, and there's a lot of details in here. So again, I'm not going to go through it, but you can see graphics and examples. Most crawl spaces are going to need plastic as well. That is a class 1 vapor retarder. The only exception would be what I call a highly vented crawl space. Down here it says highly vented. It's got basically 1 square foot or more net free area for every 100 square feet. It's like a house on piers, but most crawl spaces have to have plastic. So here's examples. And then if you're going to do floor insulation, again, I'm not a big fan of it, but here's how much you need depending on what type of framing you have. So typical climate zone 3, you're looking at R19 over a crawl space or over a basement, and of course it has to be up against the subfloor. So there you go. And then with a cantilevered floor, it's R30, because that's over outside air. That certainly makes sense. We want to block that, insulate to more insulation, R30 instead of R19. So here's another diagram that shows floor insulation. And then wall insulation. Well, here's a big section. Lots of code references here. Basically, what Georgia amended, the wall was supposed to be R20 for climate zone 3. They kept it at R13. And you know, I do want to, this is a good one. No vapor retarders anywhere required in climate zones 2 through 4. So you can use unfaced insulation. We actually prefer it. I think it's neater, looks better. And here's some pictures. So we're looking for good, no compression, complete coverage, bad, yeah, good, really, really bad, and like again, that description. So here's some of the graphics out of the appendix. This is the graphic for voids, and there's a graphic for compression. Mass walls, that'd be somebody building a above grade wall out of concrete typically, or cinder blocks or something. Not real common, but the R value depends on where you put the insulation. If you put it on the outside continuous, it's R8. If it's on the inside, it's R13. You know, an ICF is a great example of a product that exceeds the code, you know, much more than R8, and usually on both sides. Ceiling insulation, the simple answer here is all ceilings have to be R38. That's prescriptive, but very commonly you're going to see someone want to do a trade-off, such as R20 spray foam. So you can again, read the details, look through all that. There's, oh, we got some graphics glitches on my version here.
Oh, yeah, it's glitching.
Yeah, that's glitching on me. So that comes up clean, I think, in the actual code or something. So we'll have to check that. Ollie, we make a note of that. We'll just have to follow up with that. And again, if you do spray foam, it's called air impermeable insulation. That would have to be R20 on the roof line. And again, pictures of that. So if you do R20 on the roof line, that's fine, but you can't trade it to less than that. And you're gonna, and it says R20, you're gonna have to show a trade-off. Okay, not gonna meet code prescriptively. So if you do loose fill insulation, usually you're gonna have some sort of a soffit dam so that it does not fill up the soffit, and then the eave baffle, and that's gonna have to clear the top of the intended insulation about 4 inches. So just hypothetically, if you're trying to blow R38 and that's around 14 inches, the top of this baffle needs to be 18 inches above the flat ceiling. Okay. And again, pictures. It's always important that the baffle extend over the top plate. All right, attic access, really no changes on this. It's basically R5 and the pull down stairs and the wall doors, 19 on the scuttle hole. I think most builders are probably doing something like this. It is possible to do it. Oh, here's a good picture. Shows an important detail, needing to air seal. This door, of all the doors and windows that need to be sealed in the rough opening, this is the most critical one, and a lot of times it isn't done. So that's good. That needs air sealing. And here's an example of a pull down stairs that has the foam in the door, and they also have a foam cover box or a zipper tent. And that's a good idea to go beyond code, but for code, you just probably need one or the other. And I think it says that either option will satisfy code. All right, cruising along. Attic knee wall, really no changes here, but some great diagrams showing the need for blocking, sealing the blocking, insulation, and then some sort of sealed air barrier on the back of the knee wall. Generally, it's a rigid sheathing of some form. Here's a great diagram out of the code. And here's some pictures. Here's kind of bad and good. And now we're on to fenestration. So fenestration is essentially windows and doors. And prescriptively, it's 0.35 is the entire statewide requirement. So this is good for everybody. It's an area weighted average, so some could be worse, some could be better, and you can still stay prescriptive as long as the weighted average meets it. By the way, I'm going to jump ship for a second and say up here on our website is a weighted average U-factor calculator tool. You can download that and you can put in your windows and you can see the impact of, it'll do the weighted average calculation for U-factor and solar heat gain. So if you got 3 different kinds of windows, one meets code, one is worse than code, one is better than code, based on the area and how much better or worse they are, this will do the math for you. I just want to make sure everybody saw that. Okay. In general, that's the U-factor that we want to be low. And there's also one for skylights. And then for solar heat gain, it's 0.27. So that really should say 0.27 right there. But 0.30 is actually allowed because that's the worst it can be, 0.30. So with a trade-off, that window could still work, but other windows need to come in below 0.27 to kind of offset that particular one. What we don't want is something that's 0.31. That's not going to pass code. So the worst case that you can be on windows is a 0.5 on U-factor and a 0.3 on solar heat gain. This window is meeting the 0.35 U-factor. It's not meeting the prescriptive, but it is allowed to be traded, so it's acceptable. Fenestration air leakage, I wouldn't worry too much about that. It's usually relatively airtight. There's a term there. Can lights, no change on this. It needs to be airtight and IC rated. And you can see there's a slotted fixture that's just a disaster. It's very leaky. And here's one that's like a can inside a can. If you air seal and insulate the tub, you always want to make sure you insulate, put an air barrier, seal it before you set the tub. Usually that's a rigid air barrier, like in this example here. And of course, anytime you have a tub that the floor is insulated, there's air sealing. In the rough openings, you can use backer rod, you can use caulk, but generally people are going to use a low expansion, usually in a blue can, spray foam made for windows and doors. Garage separation details. I think I'm going to pick up the pace a little bit, Ollie, but how are we doing time-wise? Are you going to cut me off here? Am I okay?
Let's go for a little bit longer.
All right, let's see if we can. I'd like to finish this, and I don't want to rush on it, but air sealing, yeah, air sealing the attic, or excuse me, garages, particularly when there's like an attached basement. You can see, you know, that they tried to make the stairs in essence be the air barrier, and they didn't block it behind it, and that's a huge leak, and that'll show up when you blower door test. That'll fail. So. The bottom and the top plates it's the penetrations that are a big deal, so at the bottom plate we like to caulk the inside edge with a bead of caulk and glue underneath it, or double bead of caulk underneath it when you set the wall, or gasket. I like gasketing as well. But this inside edge right here, it may not seem big, but that crack really adds up, and I've seen houses fail blower doors because of that crack. This is a nice detail if you really want, or want to make sure your house is tight. This is the interior wall top plate. You get up in it and you seal it before you do the loose fill. Okay, and then of course the band joist between first and second floor. That's always a critical point, and a lot of times that's where if you have sheathing that's been sealed at the gaps of the sheathing, that will help. Otherwise, this is often very leaky. It is, your air barrier, you can always have more than one. It is recommended that your air barrier in new construction, I always say focus on the sheathing. So you can seal the gaps in the sheathing. You are allowed to use house wrap that's taped and sealed as your sort of air barrier on the outside. My personal experience is that doesn't, that has a lot of holes poked in it, and it doesn't really get detailed correctly, but it can be done. So I tend to say focus on the sheathing itself. If the seams of the sheathing are sealed. I really like this product. It's made in Georgia. It's a zip system. It's got really good sealing. There's a lot of ways to make a wall tight and make a wall weather barrier. So these are just a couple examples. Utility penetrations, those in sheathing in particular need to be done, as well as through top plates. Those are kind of common places, but generally we see people are actually doing the air sealing here. This is an extremely important one, making sure duct boots get sealed to the drywall or the subfloor coming up from underneath. That will show up in your blower door test, but it will kill you in your duct leakage test. We're going to significantly tighter ducts next year. So that one's going to have to get done, or else you're not passing if that doesn't get sealed. And then again, any, bath fan penetrations through, that needs to be sealed through the band. Drop soffit, or that's a good example of a drop soffit. That needs to be air sealed and insulated at the top. Cap that chase. Here's pictures of chases. This one has been capped. And then if they need to cut a hole for something, they'll run it down inside there. Here's one that, well, A for effort, but an F for execution. Here's one that looks like they got it right. They capped the chase, the sub cut the hole they needed, they ran their duct, they sealed it. That's what you want. And then on the rim, in the band area, again, we want to air seal it and then also insulate it. So I think this diagram does well. And this is pipe insulation for mechanical fluids. It's really funny. It's R3, and you go, okay, it's R3, until you go to the mechanical code and it says refrigerant suction lines are R4. So that's just something to be aware of. I don't know why it's not really a conflict, but it's sort of confusing. Hot water pipe insulation of R3 is required on any hot water pipe that meets any of these bullets. So anything that's 3/4 inch or bigger, anything that is outside the conditioned space, anything that is running through to a manifold, any buried piping, and any piping in a recirculation system, unless it's a demand recirculation system. So those are big. Pipe insulation, Ollie, that is new next year. So you know, I hope everyone caught you nodding your head on the camera there. I didn't know what to say. I didn't give you much to say. There's someone insulating a pipe. And then hot water, basically, there's a lot of incentive to put in a circulation system if your plumbing source of hot water is more than 50 feet from the farthest fixture. You pretty much have to put in a circulation system. And this is not the energy code. This is actually a Georgia plumbing code amendment. You can put the pump anywhere. The pump can be at the water heater, can be at the last fixture. The better control, some people control it with a timer, some people control it with thermostat. As you can imagine, all that piping has to be insulated. The better systems are what's called on demand, where they don't run the pump all the time. You actually walk in the bathroom and push a button, or you walk in the bathroom and an occupancy sensor says, hey, you want hot water? I'm going to run the pump, and you get hot water very quickly and it shuts off. And a lot of times you don't even have to have this extra return line. You just pump the lukewarm hot water through the lukewarm cold line back into the tank. So you don't always have to have that extra return line. Okay. Really no change on duct insulation. R8 if it's in an attic, R6 if it's in a, like an unconditioned crawl space. That's probably the big takeaway there. Technically it's R0 if the ducts are inside the envelope. I don't know that I agree with that because you could have sweating on the ducts, but that's what the code says. And then sealing ducts, no change on this. Got to use mastic. Do you remember how thick the mastic has to be, Ollie?
Off the top of my head.
Do you remember the gauge that we use? The answer is 2 millimeters thick. Or the thickness of what coin, Ollie? That's the thickness of a nickel. So if you turn the thickness of a nickel, that's how thick the mastic needs to be. And that means you're not going to be able to read the writing on the tape if you're masticing over tape or something. It's thick. You got to plug it on there. You don't want to paint it so much as push it on there. So here's some good pictures. Here's some bad pictures. Here's another bad.
That stuff actually happens.
Yeah, I think these two captions are backwards because this one it looks like it has silver tape, but this one definitely doesn't. But it doesn't. Neither one passes. So okay. And here's something new. Where should I seal with mastic? Well, we've got some graphics and diagrams. Again, this is a big one. Getting that boot to the subfloor or the ceiling. And you don't ever want to use a building cavity as a duct. It often gets violated and it leaks to attics and things like that. So don't do that. And that's pretty much it for that. So we're on to heating and cooling equipment. Really not any major changes here. You're going to be filling in, a mechanical contractor usually fills in this section of the energy code certificate. Essentially you use manual J to calculate a load, and then you use manual S to select equipment that can deliver and always meet the load, or meet the load, satisfy the load. So you summarize this information in essence on the energy code certificate, which is usually mounted at the electric panel. No real change here. You can't use an electric furnace as your primary heating source. It's if you're going to have a ducted air system like an air conditioner, you might as well make it a heat pump. Heat pumps are so much more efficient than electric resistance. So that's just a really kind of one of those very fast payback things or no-brainer things. Programmable thermostats are required for heat pumps as well as furnaces. The big heat pump control is that we want this thing called something to prevent the electric resistance heat in the winter from turning on when it's not cold outside. For example, in somebody's house that has a heat pump, let's say it's 54 degrees outside. And if they change their thermostat from, say, 67 to 70 degrees, anything more than a couple degrees, a lot of times the electric resistance will kick on. And that's silly if it's only 54 degrees out. So what this thing does down here is, and it should be turned to 40, it should say the strip heat can't kick on unless the outdoor temperature is truly cold. And what we did is we defined cold as anything below 40. Cold is 40, right, Ollie? Is that right? Yeah. Isn't that where water freezes? If I remember right?
Yeah.
40, something like that.
The 30s.
Okay. So anyway, that's a good idea, and that's an example of a lockout. So this section talks about the fact that we're building pretty tight houses under this new code, and in climate zones 3 and 4, I would certainly suggest the same for climate zone 2. You don't want to get combustion air and people air from inside the house, and we don't want to sort of make the atmospheric combustion appliance compete with me for oxygen. So we want to either upgrade the appliance or relocate it, like put a water heater in the garage, or put it inside a combustion closet. I think we have a diagram of this, like here, yeah. So here, this is a standard water heater. It's using the air around it to burn with, but instead of a louver door and trying to get this combustion air from the house, which is not a good idea because it's a tight house, we're going to actually seal this off, make a little chamber, and bring high-low air from an unconditioned, say, a vented attic space. So one way to think about this, Ali, is that you could put the water heater up in the attic, or you could build this sort of sealed insulated box and connect the attic to it. So it's kind of like extending the attic down around the water heater. And so that's a safe way of doing it. And as long as that door stays closed, and I actually like to put a label on that door that says keep this door closed at all time, because it really should be. And then in terms of fresh air, this is a real quick summary of this, but basically you figure out how much ventilation you need from this chart. If you need it, you're required to have it if you're below 3 ACH 50, thanks to the amended code in Georgia. You can do intermittent, and your air intakes and exhausts all have to have dampers, and they have to meet a certain minimum fan efficiency. And if you use your big blower as your fresh air duct, it needs to be an ECM motor, which at first I thought might be a big deal, but my understanding is a lot of equipment is going to require, pretty much, I think all furnaces next year are going to require that. And I think a lot of heat pumps might have that too. So we always recommend fresh air, and we're going to try to meet it to code, even though Georgia did amend that for certain houses. All right. No change on this. Power attic vent fans that are tied to a grid in terms of powering the motor, not a good idea. We will allow you to do a solar powered one, but I don't necessarily recommend it. They tend to suck air out of the attic, which is great, but then they end up, that air gets replaced by leaks from the house. So that's not a good thing. And again, as I mentioned, your dampers are required at intakes and exhausts. And you got to pass a duct tightness test of 6%, which is pretty good. And 6% means if that duct system serves, it's 6% of the zone area. So if the duct serves a zone that's 1,000 square feet, 6% is 60. Okay, there's a little sample where that would be filled in on the certificate. And blower door is a similar kind of thing. Every new home has to pass a blower door test. It's less than 5 ACH 50 for single family, and it gets filled in on that part of the checklist. There's a blower door, and so on. And then the certificate for compliance, I think we mentioned this already. Here's a little bit more detail. This is the version that we want you to use for the whole state. It may get a couple slight tweaks to it, but I think this is more or less what we're looking to see, trying to get everyone to use the same one consistently. And then lighting it goes up from 50% lighting to 75%, and that is essentially LED. Is this LED, and compact fluorescence would work, but today, if you're going to buy new bulbs, don't buy CFLs because they have mercury in them, and they're never as efficient. So the best approach is LED. One more kind of tag along here. Wood burning fireplaces, basically they need to have combustion air brought to the firebox, and then they're correctly vented up through a flue, and the flue has to have a damper. So you got a damper here and a damper here, and if it's not a tight fitting flue damper, if it's not, the flue damper isn't tight, you have to use tight fitting glass doors. Okay. And I think I'm at the tail end about heated swimming pools and spas, so I'm not going to bother to read that one. But Ollie, what did we miss?
I don't think we missed anything. We went straight through everything.
I feel like we covered the entire code in a decent amount of detail, but mainly we tried to let you know where some of these great tools are. So again, I'll summarize by going back to this page again of where do I get this information from? It's southface.org, education, courses, energy code, Georgia Energy Code. All right,
Yep.
Sounds good.
We're good.
Thanks for watching.
Thanks, everyone.